Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video we are going to study about capacitive transducers. We will study what are capacitive transducers, then we will see some of its applications, advantages and disadvantages. So let us start with our topic. So what are capacitive transducers? As the name says that they are a type of transducers, and if we see what is a transducer, then transducer is a device which converts a non-electrical quantity into an electrical quantity. So we can say that capacitive transducers, they are going to also convert a non-electrical quantity into an electrical quantity, but they are going to use the principle of conversion, which means that the non-electrical quantity is doing some changes in the capacitance, and due to the change in the capacitance, the non-electrical quantity is converted into an electrical quantity. Okay, so capacitive transducers. So capacitive transducers, they convert a non-electrical quantity into an electrical quantity by means of changes in the capacitance. Okay. Now the non-electrical quantity, it can be either displacement, force, pressure, flow, level or torque, etc. So these are all physical quantities or the non-electrical quantity, and they are converted into an electrical quantity which can be voltage or current. Okay. Now how they are converted? By means of changes in the capacitance. Means these physical quantities, due to the changes in these physical quantity, the capacitance is going to change, and due to that the voltage or current is being generated in the output. Okay, so that is what a capacitive transducer is. Now the principle of operation of these capacitive transducers, they are based on the equation of capacitance. The relationship of the capacitance, that how we define the capacitance of a capacitor, on the basis of that equation, the principle of working of capacitive transducer is based on. So the principle of operation of capacitive transducer is based on the equation of capacitance of a parallel plate capacitor. If we see a parallel plate capacitor, if we see its diagram, it will be like So if we see the diagram for the parallel plate capacitor, parallel plate means we are having two plates, top plate and the bottom plate, which are kept parallel to each other at a distance d between them. Now in between these two plates we are having a dielectric medium, okay, and the width of these plates is W and the length is L, and D is the distance between the two plates. So for this parallel plate capacitor, the capacitance is given by the equation C is equals to epsilon A by D, or we can say it is epsilon R epsilon naught A by D, where epsilon is the permittivity of the medium, epsilon R is the relative permittivity, and epsilon naught, it is the permittivity of the free space. A is the area, overlapping area of the plates, D is the distance between the plates. So if we see all these parameters, epsilon is the permittivity of medium. Medium means the dielectric medium which is used between the two plates. So it is equal to epsilon R epsilon naught. Epsilon R is relative permittivity. Epsilon naught is the permittivity of free space. It has a constant value which is 8.85 into 10 raised to the power minus 12 farads per meter. Okay. Then A is the overlapping area of plates, and D is the distance. So for a parallel plate capacitor, the capacitance, it depends upon the relative permittivity, on the area and on the distance between the two plates. Now this permittivity, it depends upon the dielectric medium which is used between the two plates. So for different dielectric medium, the value of the permittivity will be different. So we can say that the capacitive transducers which are working on this equation, if by any means we are changing the capacitance, means if we are changing any of these variables, then we can convert the non-electrical quantity into the electrical quantity. So by any means they are using the principle of change of capacitance, and capacitance can be changed by changing any of these variables. So the capacitive transducers, they also work on the principle of changing any of these parameters. So the three variables which can be changed to cause the change in capacitance are change in overlapping area, change in distance d between the plates, and change in the dielectric constant. Now the changes in these three parameters, it can be done by the physical variables like the displacement, force, pressure, or any liquid. Liquid level can also be there, and liquid flow can also be there. So displacement, if due to displacement the overlapping area or the distance between the plates is changing, then capacitance will change. If force or pressure is being applied to change the area and the distance, then also capacitance is changed. If we change the dielectric constant, like if in the liquid level measurements or the flow measurements, due to the liquid level or the flow, the dielectric constant changes, so capacitance also changes. So the changes in these parameters can be done by these physical variables or the non-electrical quantity. So we can use this change in the quantity to get the change in capacitance, and we can get an output quantity. Okay. Now in this capacitive transducer, the capacitance, it can be measured with the help of the bridge circuits. In that case, the output impedance is given by, output impedance will be XC. So XC will be 1 upon 2 pi FC, where F is the frequency and C is the capacitance. So we can use bridge circuits to measure the capacitance or the output capacitance impedance of the capacitive transducers. Now you have seen here that we can use any of the physical variable to cause the changes in either the overlapping area or the distance between the plates and the dielectric constant. So there are various types of capacitive transducers which are using this principle to convert a non-electrical quantity into an electrical quantity. Now let us see some of the advantages and disadvantages of the capacitive transducers. First we will see the advantages. Now the capacitive transducers, they are a type of passive transducer, means they require an auxiliary source for their operation for the conversion of non-electrical to electrical quantity. Now this auxiliary source has to be provided externally, so they are called the externally generated or externally powered transducers. Okay. Now the capacitive transducers, they require extremely small force to operate them. So the auxiliary source which is providing the power, they require very small power for their operation or for the conversion. So they can be used for the in the systems, in small systems they can be used, which are using or which are consuming very less power. So it's an advantage of capacitive transducer that they require extremely small forces to operate them, and hence they are very useful for use in the small systems. Next advantage of capacitive transducer is that they are extremely sensitive. They are highly sensitive devices, so they can be used for very small measurements also, because for small difference or small changes they are going to produce a large output. So they are highly sensitive. They are having a good frequency response. Their output is very high as the frequency increases. So they are having very good frequency response. Their output is very high as the frequencies increase, like 50 Hz of frequency. So they can be used for the dynamic changes also, for the dynamic studies also. The capacitive transducers, they are having very high input impedance. So due to this high input impedance, the loading effects are minimized in the system, because there is a condition for loading effect that the device should have a high input impedance and low output impedance. So capacitive transducer having very high impedance, high input impedance, they are in that cases loading effects will be minimum. With the help of capacitive transducers, a resolution of the order of 2.5 into 10 raised to the power minus 3 mm can be obtained. So capacitive transducer, they are having very good resolutions. Very minute changes in the displacement can be easily measured with the help of these transducers. Now, as in the first point, I have said that these are passive transducer. They will require some external force to do the conversion. So the force requirements, they are very small, and due to that they require very small power to operate them, because the power which is provided from the external source, which is used for the conversion process. Now small forces required, it means small power is used to operate them. Okay, so force requirements are small, so they require small power to operate them. So these are some of the advantages of the capacitive transducers. Now let us see some of the disadvantages of capacitive transducers. So the metallic parts of the capacitive transducers, they must be insulated from each other. Insulation should be provided so that any stray capacitances or the capacitance which are in the surrounding area of these transducer, that is not going to affect the actual value of the capacitance. So to reduce the effects of the stray capacitance, the metallic parts of the transducer, they must be insulated from each other. So that is a disadvantage, that the capacitive transducers, they are affected due to the presence of stray capacitances. Now these capacitive transducers, they sometimes show non-linear behavior due to the presence of edge effects. Now to reduce these effects, guard rings are used to eliminate this effect. So that is also a disadvantage, that the capacitive transducer, they are showing non-linear behavior on account of the edge effects. Now, in the capacitive transducer, when we have studied the advantage, we have seen that it is having high input impedance. So, loading effects are minimized. But the output impedance is also high of the capacitive transducer. But for loading effects, it is required that output impedance should be low. So, due to the high output impedance, there is some value of loading effect produced in the case of capacitive transducer. So the output impedance is high on account of the small value of the capacitance of these transducers, and this leads to the loading effects. Now the cable which is connecting the capacitive transducer to the measuring point, it is also a source of error, because this cable is also going to have some impedance value. So that impedance value will be added in the value of the capacitance, and when we are measuring the changes in the capacitance, there will be an error in the measurement due to the impedance value of these cables also connecting leads also. So this also leads to an error in the case of capacitive transducers. So these are some of the disadvantages of the capacitive transducers. Now let us come to the application or the uses of capacitive transducers. Now, as we have studied in the earlier, that the capacitive transducers, they are used for the measurement of the physical quantities, displacement, flow, pressure, level and torque. So these physical quantities are measured by changing the capacitance, and they are converted into the electrical quantities. So let us see the applications of capacitive transducer. The first application of capacitive transducers are that it can be used for the measurement of both linear and the angular displacements. The capacitive transducers, they are very sensitive transducers, so they can measure very small or extremely small displacements which are of the order of molecular displacements, that is 0.1 into 10 raised to the power minus 6 mm. So such small displacements, they can also be measured with the help of capacitive transducers, and also very large displacements which are up to 30 meters, they can also be measured, like in the case of aeroplane altimeters. They are used for both the small displacement measures and the large displacement measures, and also both linear and angular displacements can be measured. Now for the measurement of displacement, the change in the area of the plates and also the change in the distance between the plates, they can be used. So both these principles, change in the overlapping area of the plates and change in the distance between the plates, can be used for the displacement measurement by the capacitive transducers. So that is the first application or first use of capacitive transducer. Second application is The capacitive transducers, they can also be used for the measurement of force and pressure. First, the force and pressure, they are converted into displacement, and then the displacement is going to change the capacitance. So in this way, force and pressure, they can be measured. They will be first converted into displacement, and displacement is going to cause the changes in the capacitance. So indirectly, we can measure the force and pressure also with the help of capacitive transducers. Now the capacitive transducers, they can also directly measure the pressure also in all those cases where the dielectric constant of a medium changes due to the change in the pressure. Okay, so indirectly the pressure can also be measured by converting it into displacement, and directly also if the changes in the pressure, they are causing the changes in the dielectric constant, and which is changing the capacitance, then they can directly measure the pressure also. Now they are also used for the measurement of humidity in the gases, because the dielectric constant, it changes with the change in the humidity. So as the humidity changes, the dielectric constant also changes and the capacitance also changes. So it can be used for the measurement of humidity also. Now capacitive transducers, they are also used in conjunction with the mechanical modifiers for measurement of volume, density, liquid level, weight, etc. All these are the mechanical quantities. So the displacement means either of these quantities, they will be directly measured by the change in the capacitance. Like if we take the case of liquid level, so if the level of the liquid increases, the dielectric constant, its amount also changes between the capacitance plates, so due to which the change in the capacitance occurs. So level is causing the change in dielectric constant, and dielectric constant is changing the capacitance. So in this way, the liquid level can be measured by change in the capacitance. Similarly, the volume, density, weight, torque, all these quantities can also be measured with the help of the capacitive transducers. So in the applications, we have seen that the capacitive transducers, they can be used for the measurement of different types of physical quantities like displacement, force, pressure, level, flow, volume, density, weight, torque, and many other physical quantities can be measured with the help of capacitive transducers. So in this video, we studied that what is a capacitive transducer, what is their principle of operation, and we have seen their advantages, disadvantages, and the applications. So I hope that this topic is now clear to you. Thank you.